Hello guys. I know none of you guys are waiting for my video, but I'm back with the video. Today we're going to solve this lead code question, which is minimum difficulty of a job. Okay, let's dive into this. This, the problem description is a bit tricky to understand. So what I did was, I break down the problem statement into three important points. Okay, let me explain how problem it should be solved. In this problem, you're jobs, given a set of jobs, an array of jobs, and what you need to do is just do at least one job a day. For every day, you must do at least one job, and you can do any number of jobs in it. And what the target that you need to do is must complete all the jobs at the end of all the days. Basically, you're given a set of tasks, and you're given number of days to complete. It's like suppose we have 6 chapters to complete in 2 days. It's like that. And there's an important point here. Jobs are dependent. If you want to do one particular job, all the previous jobs must be completed. Just like, if you want to complete this chapter, you must complete all the previous chapters, complete this chapter. Basically, what we need to do is we are given number of days and we are given a particular number of tasks complete. Suppose these are the number of tasks and we are given 2 days to complete it. What's the question is asking us to do? Suppose if you complete these three tasks on day one, suppose let's assume if you complete these three tasks on day one and these three tasks on day two, and you know, the question is asking you to return the maximum effort that you keep to complete all the chapters or jobs. The maximum effort that for a day is the maximum amount of work done for one job. Suppose if in some simple words, if you complete these three jobs in one day, the maximum value is the effort for the day. And if you complete these three jobs in the second day, three is the maximum effort that you put, right? So three is the maximum work done on the second day. So 6 plus 3 is 9. So the answer is 9. Suppose you do these four tasks on day one. The maximum effort you put is 6, right? And is 2 on the second day. The maximum effort you put is 2, right? 6 plus 2 is 8. So what you need to do is you must complete all the tasks on the given number of days, and you need to return the minimum amount of effort that you can put in order to complete these jobs. Okay. Now let's try to break this problem. Let's try to, you know, think how we can solve this. Suppose we have these 6 jobs to perform in 2 days. Suppose we have only 2 days and assume this as chapters that we need to complete before an exam. So what we'll do is, we're obviously very lazy. So what we'll do is we'll perform all these tasks on day two and perform none of the tasks on day one, right? But here this is not the case because we need to perform at least one job on a day. So I have no other option to complete this task on day one, and I can perform all these tasks on day two, right? Okay, don't focus on this thing, just focus on these things that I'm explaining. This will make sense later. So I have only 2 days, so I'm completing the first task on the day one, the remaining tasks on day two, because I got no other option, right? So there is another option, right? I can do these two tasks on day one and complete all the remaining tasks on day two. This is one of the option. And what I can do is some sort of another option. I can perform these three tasks on day one and the remaining tasks on day two. And I have another option. I can perform four tasks on day one remaining tasks day 2, and I can perform 5 tasks on day 1, and I can perform the one task on day 2. So if you observe carefully, we have so many options. And what is the effort that is taken to do like this? If you see here, the maximum amount of work that I put here is 6, plus the maximum amount of work that I'm putting here is what is the maximum effort task, which is 5, right? 5 give 11. So if I do like this, I'm putting an effort of 11. And if you look at here, what is the maximum? Okay, now you look at this. This is day 1, right? In this day, the maximum effort that we are keeping is 6, plus the maximum effort that we are keeping on the second day is 4, right? So the value is 10. And in this day, the maximum effort we are keeping is 6, plus the maximum effort that we are keeping here is 3, which is 9. In this day, where the maximum effort is 6 plus 2, which is 8. This day, the maximum keeping is 6, plus on second day, we're keeping only 1. So the answer is 7. Let's look at another example. Look at this example. Suppose we're taking the same array, but we're having number of days as 3. Number of days as 3. So what I'm doing is, on the first day, I'm only performing 6. On the second day, I'm performing 5. On the third day, I'm performing all the remaining tasks. So my answer will be 6 plus 5 plus the maximum in this, which is 4. So this will be 10 and 15. On the second what call the second option is 6, plus on the second day I'm doing 5 comma 4, and on the third day I'm doing 3 comma 2 comma 1. The answer will be 6 plus 5, 11 and 15. Okay. If you look at this, the first day I'm only performing 6. On the second day I'm performing 5 comma 4 comma 3. On the third day I'm performing 2. So it will be 6 plus 5 plus 2 be 9 plus 2, which is 11. So in this way we can evaluate each and every possibility, and we need to return the minimum answer that we are getting. That is the question. And now, okay, how are we going to do this? Is the main is the main. If you observe this question carefully, if you observe this question carefully, we're just evaluating each and every possibility, right? Look at this. Just evaluating each and every possibility. Look at this. I'm only performing 6 on day 1. This is day 1. This is day 2 and day 3, right? On the first day, I'm only performing 6. On the second day, I'm only performing 5. On the third day, I'm performing the remaining. Like this, when I'm performing only one task on day 1, these are the possibilities that we are getting. And when I'm performing 2 tasks on day 1, these are the possibilities that I'm getting. When I'm performing 3 tasks on day 1, these are the possibilities. And when I'm performing tasks day 1, day 2, these are the possibilities. We're just evaluating each and every possibility, the situation. When it comes to evaluating each and every possibility, a thing that comes to our mind is recursion. Recursion. Recursion helps us to evaluate each and every possibility, and take the best possibility of each and every answer that we're getting. So how are we going to perform this recursion on our problem? Look at this carefully. This is index 0, right? X1, 3, 4, and 5. 2, and 5. What recursion does is assume f is a function where the parameters are where the parameters are x comma number of days f of the index. Initially the index is 0, right? 0. The number of days we have is 2. Then what we will do is, what the recursion function does is it will take it will perform 6 on the first day, and let the recursive call take it asks the recursive call to take care of the remaining array. We're taking f of I'm completing zeroth task. Uh, Basically, what we'll do is in this function is we'll take the opposite of the number days. Nothing but I'll perform I'll perform all these tasks on day 0, this task on day 1, and this task on day 2. All these things on day 0, this will on day 1, this thing on day 2. Just like that, just like that, you know. What I'm saying is I'm only performing one task on my day 2. I'm only performing one task on my day 2, and then I'll go to index number 1. I'll go to index number 1 with only 1 day left, right? Initially we have 2 days, but on the first day we only perform the 0th task. So this function will take 1 as index, and the remaining number of days is 1. And we also have another possibility. What if we perform 2 tasks on day 1, right? Will be f of will go when we perform tasks, that is 6 comma 5, we come to x2, but we only have 1 day left. What if we perform 3 tasks on day 1? We'll come to index 3, and we only have 1 day left. What if we perform 4 tasks on what if we perform 4 tasks, 1 2 3 4? We'll come to index 4, and we only have 1 day left, right? What if we perform 5 tasks on day 1? Of will come to 5, and we only have 1 day left. Now these are all the function calls that are made by this function. Now these function calls will be evaluated from left to right, right? Recursion. This function behaves exactly similar to this function. This will call this will from index 1 it will perform initial one task. If it performs one task, it will call index 2 with 0 days left, right? If you observe carefully, we performed we performed one task on day one task, sorry, which is 5, sorry, 6. We performed one task on day 1, and we performed one task on day 2, and we said you have 0 days left, and you have 4 comma 3 comma 3 comma 1 left to perform in 0 days, which is not possible, right? So we have 0 days left, so it is a base condition. So we'll return -1, right? And let's assume we have let's assume we perform 2 tasks now. Initially we perform one task. From 1 we are performing 2 tasks, which is 5 comma 4 we are performing. So we'll go to index 3 with 0 days left. So we went to index 3 with 0 days left. So this is not possible. So will return -1. And another possible way is we perform three tasks. So then we'll go to index 4 with 0 days left. So what is happening here is we performed 6 on day 1 and we're performing three more tasks, which is 5 comma 4 comma 3 on day 2, and we are leaving 2 comma 1 for day 3, but we don't have any day left. So this will also return -1, and this will also call the same thing. F of 5 comma 0 means we're performing four tasks, 6 comma 6 on the day 1 and 5 comma 3 comma 2 on day 2, and we're leaving 1 for the day 3, which is not possible. So another function call is 5 tasks, performing 5 tasks. F of we'll be going to 6 and we will be only having 0 days, right? So what we're doing is we're performing the I'm sorry, first task on day 1, the remaining all tasks 5 comma 4 comma 3 comma 1 on day 2. So we're left with no tasks, right? So this is one of the possible condition. So this will return 0, will return 0. Like this, we explore each and every possibility and see which one gives answer. But there is one thing to note here, when we are traversing from left to right, at the same time we keep track of the maximum element, right? Suppose you're performing 4, 3, 2, 1. So at the same time we keep track of 4 as our largest element. That's what I'm trying to say, and let's see how we are going to implement this. If you observe this carefully, we're going from the index. This is index, right? This is days. We're going from index +1 to array dot length -1. So it's a for loop. We're going from x equals to, let's assume we have a function which has index comma int days, right? What we are doing is we're going from I equals to x+1, right? We're having x as 0, so we're starting from index +1 and we're going till I less than, we will be given with an array, right? Array dot length I plus plus. And what we are doing here is we'll be have a max as -infinity, and sorry, we'll have yes. And what we'll do is for every iteration we're calling a function, right? For every iteration we're calling the same function, but now the index is I, the number of days is day -1, right? Here what we'll do is, okay, we'll keep track of the max, right? Max equals mat dot max of max comma array of I. Keep track of max, and our answer will be our answer, and thing is, let me explain you with another example. Let's take an example like 6 3 comma comma 5 comma. Let's assume this is our example and our number of days equals to 3. Assume now if you look at our function, come on. Okay, if you let's take this example. Our function is like f of the index initial will be 0 and the number of days will be 3, right? So what this function does is will say I'll only perform one task. I perform only one task. So what I'll do is I'll go to index 1 and the number of days remaining will be 2, right? So what is the another possibility? We'll say I'll perform two tasks. Perform two tasks. When I perform two tasks, so I'll go to index 2, right? This is 0, 1 and 2. I'll go to index 2 with number of days remaining is 2. And I'll perform three tasks. Then I'll go to 3 comma. I'll perform four tasks. Then I'll go to 4 comma. I'll perform five tasks. Then I'll go to 5 comma 2. Let's assume we're evaluating this thing. I'm just writing the thing down so that it won't get clumsy. So if you observe carefully, what's happening here is on the first day, on the first day we only perform this thing. So forget about this. We only have this array from index 1 to end. Now we only have 2 days. Now what this will do is it will also say I'll only perform one task on my day. I'll only perform this task. So then where I'll go? We perform 0, 1, then I'll go to 2, right? 2 with only one day left. Since I have 2 days and I performed only one task on this day, so I'll go to left with only one day. So if I perform two tasks, it will be f of I'll go to 3 and the number of days I'll have is 1. If I perform three tasks, f, f of then I'll go to 4, the number of days will be 1. F of 5 comma 1 if I perform 4 tasks. Can I perform 5 tasks? No, I cannot, right? Because there are only 4 tasks. This will be the same thing that will be happening for this. Let me cut entire here. This is the thing that's going to happen for me. Let's evaluate this thing to get a better idea. F of 2 comma f of 2 comma 2 got overridden by the 4. So what this will say is what this will say is I'll perform only one task. Come on. Okay, now I'm going in the code. Actually, what Just checking the number of days are greater than the number of tasks. If it's the case, then we'll return minus. For this example, we have only 3 tasks, but we need to perform them in days. And we can only perform, if we have to perform at least one task on a day. On the fourth day, we cannot perform the tasks, but that's why we're calling the solve function. With the solve function, this is the base condition. When we only have one day left, then we're just returning the maximum value of remaining array. That is that is happening in function. We're just taking the current value as the max before the we keep, and as we are looping the tasks, we just keep on increasing the. We just keep on updating the max, and for every iteration, we just call the recursive function, and when it comes back, we'll compare it with the result, and we'll take the maximum of the result and the answer written by this function. We'll return it as the answer. If we submit this, it will give us a TLE, time limit exceeded, because function takes 2 power n, because take more than 2 power. For every, for every calling n recursive calls, right? So take n power n time, I guess. Now in order to submit this, getting submitted on. That's why time limit taking deep memory. Hello. To runs or not. Yeah, it will get accepted. Thank you for watching the video.